Hey guys, welcome back to our YouTube channel. Today we are going to solve the problem subarray sum equals to k. Okay, so basically in this we are given an array of integers and a integer k. Okay, so we have to give the total number of subarrays whose sum is equals to k. Okay, so basically a subarray is the continuous sequence of elements in an array. Okay. So let's say we have this example, and in this array we have 1, 1, and 1, and we need to find the subarrays with sum k is equal to 2. Okay, so this 1 plus 1 is one subarray which is give us 2. This 1 and 1 will also give us 2. So the total number of subarrays will be 2. So we have to return the total number of subarrays. So before we start proceeding in our code editor, let's think of the possible approaches to solve this problem. So we are given this array 3, 1, 2, 4. Okay. And now we have to find the total number of subarrays with sum 6. Okay. And here the value of k is 6. So let's start thinking about the approach. Okay. So the most naive or the brute force solution can be uh, you know, check all the subarrays and their sum, and if the sum is equal to 6, increase our counter, right? Basically, we can generate all our subarrays, right? And to generate all subarrays, check this. Like, what is a subarray? A subarray is a consecutive sequence, right? So let's say if I start from 3, my 3 is a subarray, 3, 1 is a subarray, 3, 1, 2 is a subarray, 3, 1, 2, 4 is also a subarray. And then 1 is a subarray, 1, 2 is a subarray, 1, 2, 4 is a subarray, and so on. Right. So it means we take one element and then start clubbing it with other elements, right? Like we start from 3, then we start from 1, right? So basically we can start iterating, and what we can do is we can start iterating from 0 to n. Okay, where n I'm assuming the length of the array. Okay, this is my I. So let's say I start iterating, and my first index is or element is 3, right? So from 3 what I can do is I can start my j. Okay, and j can be I plus 1, right? Correct. Or j can be from I, because till I to the n. Okay, so basically what it means, I start from 3, then my j will also start from this 3. So what I will do is I will I will sum whatever I have. Okay, basically I will calculate sum of each subarray. Okay, and then I will just add this sub my current element j in this you know sum. Okay, yes, so I will keep on adding my sum, and if any time my sum equals to k, basically my sum equals to k, right? That means I can increase my counter, that is c plus plus, and so on, right? And then after all the iteration, what I will get is in my counter my current subarray count. Okay, so this is the most obvious solution. Basically what we have done is we have generated all the subarrays by looping through it, by looping through each element, and then calculating the sum at each step. Okay, so let's say we start from 3, then what we did, 3 plus 1, that is 4, and we'll check 4 is equal to k, no, then what we did, 4 added 2, then 4 plus 2 is 6, yes, this is equal to k, then we increase our counter by 1. Okay, and then we start from 1. Similarly, when I becomes 1, right, that means we'll start from here. Then what we did, I plus 2, 3, right, and it is not equal to k. Then again we did 3 plus 4, 7. Okay, so that's how we started looping and generated all the subarrays and their sum. So considering the time complexity of this, it will be O of n square. Okay, where n, I am assuming the length of the array, and space complexity will be, as we are not using any extra space, it will be O of 1. Okay, it will be constant space. But here the time complexity is a lot, right? It is n square and it is not acceptable at all. So now let's think any further approach, to at least decrease this time complexity by somewhat. Okay. So let's think of a new approach and try to maybe optimize it further. So till now we have seen the brute force approach, and in the brute force approach what we did was we are checking the next element and doing the sum, and if the sum is equals to k in that particular sub array, then we are increasing our count, right? So basically in the brute force we just check the next element, right? And while doing that, the time complexity increased to n square, right? So if we have to optimize this, let's think in opposite direction. Instead of checking in my next elements, can we make it k, that is my current sum or the sum we are looking for? Let's ask our previous elements. If that sum exists already in my previous subarray. Okay, so the difference here now is, we will check in the previous elements. Okay, and by this what I meant is, take, you know, understand this with an example. Okay, let's say I have this array. Okay, and I am in, somewhere in the middle. Okay, and I'm, summing each element. Okay, and my current sum reaches 16, right? And if I tell you I am looking for a sum 6, that is my k, you know, in somewhere in between this array, like, the sum or any sub array. So what you will say? Okay, I am looking for sum 6, my current sum is 16. That means if somewhere 10 exists, right? And how you calculated that? Like, it is basic maths, right? You just subtracted 16 minus 6 and you got 10. Okay, you will say if 10 exists previously, that means some portion of array is of sum 10 and the total sum is 16. That means the remaining portion must have a sum 6, right? So we will use this approach. Basically, we will sum each element and we will subtract our k from it. And then whatever the result will be, we will check if this sum already happened in the past. If yes, then we will get to know that okay, we have got a subarray and we will increase the count. Understood? So by following this approach, okay, now how to go further in this. Now we know that okay, this 16 we can easily get, right? We will just sum each element by looping, right? And this subtraction also you can do. You know the value of k, you know the value of 16, then you can subtract. But only problem is you need to check if 10 exists, right? That means you need something to know that okay, 10 exists, right? And whenever we have to know the occurrence of any element, does it exist or not? Now, what we use, right? You people must have known till now that we use hashing. We make a hash table. And what a hash table is? A hash table is there we can maintain the records, whatever we want of the previous occurrence of the elements, right? What we have faced. So, following that approach, okay, let's create a hash table. Okay, and for now initialize it with total sum is 0, and let's assume this sum occurred only once. Okay, you will get to know why we have initialized this from zero sum. Okay. Now let's start iterating. Okay. Let's take a variable sum and my counter 0. Okay. Now let's start. My current element is 3. Okay. That means my sum becomes 3 because I initialized the sum from 0. So sum becomes 3. Now if sum is 3, that means my current sum is 3. That is, look this. And I am looking for 6. Right. That means 3 minus 6. If minus 3 have occurred earlier, that means I can have a sum 6. So I will check in my hash table, does minus 3 exist? No, it doesn't. So what I will do is, I will store the current sum 3 so that in future we can know that 3 has occurred once. Okay. Now going to the next element. That is 4. My current sum becomes 4. Now my total sum becomes 4 and I'm looking for 6. That means 4 minus 6. That means minus 2 should have occurred in this hash table. Now let's see. Does minus 2 there? No. That means I don't got the sum or my subarray right now. So I will store my sum, current sum is 4 and its occurrence as 1. Now let's go to the next element. This 4 plus 2 is will give me the sum 6. Okay. Now my current sum is 6 and I'm looking for 6. Now that means what I need have to be occurred. That is 0. And this 0 is there. That's why we have initialized the hash table with 0 sum, because if we don't initialize, then if my current sum becomes equal to k, then we will not be able to find it in the hash table, right? That's why we need the to store 0. That means this occurred and I will increase my count by 1 because 0 has occurred only once and we assume, and I will store the sum 6 and it's occurred as 1. Right. Now let's go to the next element, that is 4. So my current sum becomes 10, and if my current sum is 10 and I want 6 to occur, that means this 10 minus 6, 4 should have occurred in my hash table. Yes, it occurred, and the occurrence of 4 is 1. That means I will increase my counter by 1 and it will become 2. Right. This is my end of my iteration, and the total subarrays we got are 2 who has a sum equals to 6. Right. So hopefully you've understood this example with this dry run. And if we talk about the time complexity of this approach is of n, as we have done just one single iteration where n, I am assuming the length of the array, and we are using extra space in terms of hashing and assuming we have n elements, and the space complexity will also be of n. Okay, now we have looked through the brute force and the optimal solution, and hopefully you have understood this part. Now we have seen all the approaches, so let's get back to our code editor and let's start coding. Now we are back to our code editor, right? So before we start coding, let's see what we are given. And we are given an array nums, right? And a integer k, that is the sum which we are looking for. And in the return, we have to return a number, that is the count of the subarrays, right? So before we start, we know we need a hash table, right? With initial sum as 0 inside it, right? So let's initialize the hash table, and basically I will create an object with some 0 and its value as 1, right? Now we will loop through this array, right? That is I equal to 0, I less than nums dot length, right? And now what we will do is we will you know, sum. Okay, so that means we need to initialize two variables. And assuming my current sum is 0 and count also as 0, right? These two variables we will need. So I will sum the current element. Now what I will do is I know the remaining. Okay, what is the remaining? That means sum minus k, right? Or I can make name it better sum, or sum to be looked for in hash obj, right? This is the sum that we have to look for. Okay, my current sum is sum, and I know if I'm looking for k, then the remaining sum, that is the sum to be looked for hash object, should exist, right? If, okay, now let's check. If my hash object has this sum, or what we are looking for, right, that means it will not be equal to undefined, correct? If that is the case, that means what I will do is I will increase my counter, and the value of this counter will be whatever is present or the occurrence in the hash table, right? I will just simply use this, right? Otherwise, if it is not defined, that means we need to insert some and hash obj, right? So we will insert, and for inserting, what we will check is if sum exists, right? If sum is not equal to undefined, that means this sum already exists. That means we need to increase the value by 1 because this sum has occurred once more, right? Otherwise, if it is the sum we are inserting for the first time, that means we can, make the occurrence as 1, and that's it. Now we should have count with us, and the count should be the number of subarrays. Let's run this. Now both the test cases have been passed. Now let's submit this up and see if there are any issues or not. And see, this is submitted successfully. So I hope you have understood all the approaches and the most optimal one. So if you have any doubts, please mention in the comment section. I will be happy to help you out. And if you have understood, just write understood in the comments, and I will read all the comments. And that's it for this video. We will see you in the next one. Till then, take care. Bye bye.